Hey guys, if you have been following all the lessons in this dynamics playlist, I want to congratulate you for reaching this final lesson. In this lesson on solving GC examination questions on dynamics, we are going to cover the 5th most important and frequently asked questions, which involves a static point mass tied to 3 forces. If you search through past exam papers, you will discover that many questions are set with regards to static point mass tied to 3 forces. When we say the object is static, it means that the object is in equilibrium as a result of the 3 forces. This means that the 3 forces are balanced and there are no resultant force. Therefore, the object remains static. Let me elaborate further. In Module 2, we learned about tension in strings. When I pull this string, there are actually 3 forces acting on this box. First, as always, there is a force of gravity, that is the weight of the box. Then, there is a tension in the string where the box is being hung from the ceiling. This force is pointing upwards. Then of course there is the force of pulling the box. When the object is static, not moving, that is when these 3 forces adds up to be 0. And we say that the object is in equilibrium or the resultant force is 0. For the 3 forces to be 0, they are all pointing in one direction, either clockwise or anti-clockwise, because the sum of any 2 of the 3 forces will be equal in magnitude but opposite in direction to the 3rd force. Now let's look at how we can use the knowledge that we have just learned to solve everyday life questions. We have here a Christmas tree wall decoration, suspended by 2 strings tied to the ceiling. The tension in the strings are 1.3 Newton and 2 Newton as shown in the diagram. Determine the weight of the Christmas tree decoration. Let us reduce the size of this Christmas tree decoration to a point mass where the forces are acting on it. There are actually 3 forces. First, the weight of the Christmas decoration and the 2 tensions in the strings. When the Christmas tree decoration is stationary, it means that these 3 forces adds up to be equals to 0. This also means that the resultant force of the 2 tension forces will have a magnitude equals to the weight of the Christmas tree decoration. The resultant force of the 2 tension forces is pointing upwards, and that cancels off the weight that is pointing downwards. Now do you see why when 3 forces are in equilibrium, that is when the object is static, when there is no resultant force, the 3 forces are all pointing to a single direction? It is because the sum of any 2 of the forces will be equal in magnitude but opposite in direction to the 3rd force. So, therefore, to calculate the weight, all we need to do is to use addition of forces to find the resultant of these 2 forces. To solve this problem, we use a scale of 5 cm to represent 1 Newton. Hence, for the 2 Newton tension, it is represented by 10 cm. And for the 1.3 Newton tension, it is represented by 6.5 cm. Next, we shift the 2 Newton parallelly upwards, making sure that it is 60 degrees to the horizontal. Then we draw the resultant force. To get the magnitude of this resultant force, we use a ruler to find out its length. The ruler shows that the length of this resultant force is 12.8 cm. Since 5 cm represent 1 Newton, we take 12.8 cm divide by 5. That gives us 2.56 Newton. Since the object is static, the magnitude of this resultant force is equal to the weight of the Christmas tree decoration, which is 2.56 Newton. If you find this lesson has helped you, visit my website for more video lessons. On my website, there are practice questions that have been carefully curated to help you reinforce your understanding. remember to subscribe to my channel so that you can be alerted when I upload a new video.